Okay, so today we're going to do something a little bit different, right? We're going to look at what's called the triangle inequality theorem. So we spent the last couple weeks really just focusing on angles. And this is going to focus, we're not going to do anything, nothing to do with the angles, we're going to focus on the sides. And specifically what relationship has to be present within the sides of a triangle for us to actually be able to make one. So this is a lesson, I don't know how well it's going to go remotely because this was always a fun interactive lesson where I would present this question, can we make a triangle using any side lengths, build a triangle with side lengths of 2, 3, or 10, and I would hold a ruler in my hands and I would say, all right, who wants to come up and try this? And I would have a couple people come up and try, and I'll show you what it would look like. So they would take their ruler and they'd say, okay, here's 10. Obviously be a little straighter than mine because they'd have a ruler. There's 10, and there's 3, and there's 2. And we would say, well, what did we notice about this figure? And someone would say, well, it's not closed, right? One of the definitions of a polygon, which a triangle is a polygon, is that it's a closed figure. It's an open figure. So we're going to say, all right, well, what if I would change this to 2, 5, and 10? And then someone else would come up and they'd say, all right, I could do a little bit better. And then I'd say, well, what if I do 2, 7, and 10? And they'd say, all right, well, let me try this now. And they'd go like that. And I'd say, all right, well, that's pretty good. And I'd say, well, what if it was 2, 8, and 10? And then they would kind of, let me redraw this. So they'd say, all right, let me keep this as flat as possible. Let me keep this as flat as possible. And it would literally look like it touched. There would be an infinitely small amount of space between the segments. And we'd say, well, 2, 8, and 10 actually doesn't work. And I'd say 2, 9, and 10, and then they'd say, boom, and we make our triangle. And we'd realize, well, what has to be true? Well, the problem was these two sides were too small. These two smallest sides, their sum must be greater than the third side, and that's what we call the triangle inequality theorem. So in a triangle, in order for it to actually be a triangle, for it to be a closed figure, the sum of any, technically we say any two sides, but obviously the biggest side and the middle side is always going to be the smallest side. So informally, when we do these problems, we just talk about the smallest sides. We want the sum of the two smallest sides to be greater than the third side. And again, equal is not going to work. It's going to look like it's almost going to work, but again, there's going to be kind of like this almost infinitely small region in between where it's not actually going to close. It must be greater. So let's see how we apply that. Will this work? All right, well, let me take the two smallest sides. 4 plus 9. Is it greater than 12? And we'd put a little question mark up here. And we would say 13 is greater than 12. And we'd say that's true. So our answer would simply be yes. I can make a triangle of 4, 9, and 12 because 4 plus 9 is greater than 12. Therefore, it would be a closed figure. What about this one? So this is obviously a trap, right? So some unlucky person raises their hand and say, ooh, I know, 10 plus 27 is greater than 15. And then some more diligent person will say, but 27 is not the smallest side, that's the biggest side. And they'll say, oh, oops. And we'll say, let's see if this will work with my two smallest sides, right? Is this greater than 27? And we'd realize pretty quickly that it was a trap, and it's not. 25 is not greater than 27, so no, we could not build a triangle, right? It would maybe look like it's almost going to close, kind of like when we made, 2, 7, and 10 at the beginning, but it's not actually going to close. All right, 12, 11, and 4. That's a nice easy one. We take the two smallest sides. 4 plus 11 is in fact going to be greater than 12. I'll throw my question mark up there. So we're going to say yes, we can build that triangle. 2, 2, and 12. This should be an obvious example of one that is not going to work, right? 4 is not greater than 12. So we're going to say no. Again, get your ruler out if you'd like. It's actually going to look like that. So that certainly would not close. 7, 7, 14. Okay, let's see about this one. 7 plus 7 is greater than 14. Well, I don't know. I'll throw a little question mark up here. Is 14 greater than 14? It is not. Okay, so this is actually going to be a no. Again, it's kind of going to look like, if you actually tried to do this, it would look flat. It would look like that, and it's actually not. I didn't draw it obviously perfect, but it's not actually going to close. It's almost going to close, but it won't. So our answer for that is going to be a no because 14 is not greater than 14. So here's your now try for the first half of the lesson. So we can go over it, right? So I'm going to say 7 plus 12 is 19, which is greater than 18. I'm going to say yes. 5 plus 5 is 10. Is 10 greater than 10? That's obviously a big no. 23 plus 28 is 51. Is 51 greater than 55? That obviously is going to be a no. All right, 1 plus 2 is 3. Is 3 greater than 3? That also is going to be a no. And this is equilateral, so 7 plus 7 is 14, which is greater than 7. But again, once we realize that it's equilateral, that would be a yes. And a half plus a fourth is 3/4, which is greater than half. So this one also we would be able to say yes. Now there's another thing that we can do with the triangle inequality theorem, and it's find the range of the possible third sides. So this is another one, right, that generally it was very interactive. So I'd say, all right, guys, well, what could one of the other sides be? And someone would say, well, 7 would work because 3 plus 7 is greater than 8. I'd say that's great. And someone would say, well, we can also use 6 because 3 plus 6 is greater than 8. And I'd say great. And we'd say, what else? And someone would say, well, 9. Someone would say 10. And then we kind of hit a wall, and I say, really, that's it? And then someone would say, well, I guess 5.5 would work, right? Because 3 plus 5.5 is greater than 8. Then someone would say, oh, well, 6.5 also works. And we'd say, all right, that's nice. And then somebody would think they're very smart, and they'd say, well, what about 10.9? And I'd say, sure, 10.9 works, right? 3 plus 8 is bigger than 10.9. And then someone else would say, well, what about 10.99999? And I'd say, yeah, that works too. And someone would say, what about 5.00001? And I'd say, absolutely, all these values work. So what's the range, right? Because the question becomes, does 5 work? No. Does 11 work? No. Okay, so 5 doesn't work, but a number that's just slightly bigger than 5 works. And 11 doesn't work, but a number that's just a little bit smaller than 11 is going to work. What would that inequality look like? Well, it would be really easy. It would look like this. 5 is less than x, which is less than 11, which in normal terms means x is between 5 and 11, but it can't be either of them, okay? So that's what we would figure out on our own without learning any rules, right? We would deduce this again, just like I talked about. Now, where do those numbers come from? And I'd say, and this sometimes takes a minute or two, and I'd say stare at the numbers that were given, and then stare at the numbers that we came up with. And someone will say, 8 minus 3 is 5, and 8 plus 3 is 11. I'd say that's exactly what it is. And then we'd say to find the range of the sides, you take the difference in the two sides, right? The difference in this case being 8 minus 3, which is 5, and that's our minimum bounds. And we take the sum of the two sides, which is 8 plus 3 is 11, and that's our maximum bounds. So this should be very easy. And then the sides, the third side can be any fraction, decimal, or integer that fits in between. Two sides of a triangle are 6 and 4. Nice and easy. 6 minus 4 is 2. 6 plus 4 is 10. 2 is less than x, which has to be less than 10. Very simple. Same thing. 18 minus 10. 18 plus 10. So 8 is less than x, which is less than 28. All right, so here's your now try. So again, you can hit pause, and then we're back. So I'm going to take the difference and the sum. I'm going to take the difference and the sum. I'm going to take my difference and my sum. All right, so what do we notice here? X could be anything less than 40, right? I mean, it can't be a negative number, but when we're dealing with geometry, obviously that's taken for granted. But that's an interesting one, that if it's already isosceles, that it could be anything up, from 0 to the sum. And here we've got our difference and our sum. So whereas with number 4, the closer together they are, the bigger the range of the third side. Number 5, if our sides are already far apart, I don't have much of a range for my last side. If I've got 50, right, and I've got 1, there's not a lot of different ways that I can move this 1, right? I can basically make it like this, like this, like that. And all of those sides, whether I connect this or that or that or that, are going to be pretty close together. Just a little extension on that. All right, so your homework tonight is very simple. So this is throwing back to what we did the first half of the lesson. It's not saying find the range of the third sides. We just did that. can we make a triangle with sides of these? So I don't just want yes or no, right? It's going to take you like 3 or 4 minutes as it is. I want you to prove yes or no and why. So if the question said 5, 11, and 7, you would say 5 plus 7 is greater than 11, 12 is greater than 11. Yes, you don't need to write a sentence, but you need to do more than just put yes or no, okay? Either way, like I said, it should take you less than 5 minutes. So write out the 3 numbers, okay, like I did here. Give me the inequality, and then simply put yes or no.